This integral is challenging, and it's not only because of the infinitely nested square root. The bounds of integration also add an extra layer of complexity. We'll start by letting this infinite nested radical be some y. Notice that this part inside is y itself. One fewer term isn't going to take away anything from infinitely many terms. And so with this, we'll square both sides and solve for x in terms of y, which then allows us to express dx in terms of dy by differentiating both sides. We now have all what we need to take the integrand from the x world to the y world. We can simplify the integrand further by factoring out a y from the numerator, which cancels with the y in the denominator. But notice that the bounds are still in terms of x. These need to be transformed to y bounds. Let's start with the upper bound. When x is equal to 6, we have y squared minus y equals 6. This is a quadratic equation to which there are two solutions, positive 3 and negative 2. Y is an infinitely nested square root. It's a square root, so it must be a positive quantity. And so we reject the negative 2 and accept the positive 3. For the lower bound, doing the same thing gives us two solutions, 0 and 1. Here, it's not clear which one to reject because both of them are non-negative. So how do we know which of these is the extraneous solution brought about by the squaring we did earlier? Well, to know this, we have to look at this relationship between x and y and rearrange it to see that this is nothing but a quadratic equation in y, which we can solve using the quadratic formula. Simplifying, this becomes 1 plus or minus radical 1 plus 4x all over 2. Here, it becomes clear that the extraneous solution is the negative branch, so we have to maintain the positive one only. Y ultimately must be a positive quantity. Plugging in x equals 0 here shows that y is equal to 1 at the lower bound. So now we know that y equals 0 was the extraneous solution. Integration becomes a simple matter now. We'll expand the polynomial, use the power rule to integrate, and then plug in the bounds. When y equals 3, this is 15 halves. When y is 1, this is 1/6. So this daunting, scary integral converges to 22 over 3. That's the final answer.